In this video, we're going to learn how to use conversion factors. So conversion factors are going to help us convert between two different units, and it will show us how those two units are related to each other. So conversion factors are typically ratios, and it shows how one unit of measurement is related to another. To convert from one unit to another, we're going to use what we call an equivalent statement that relates those two units. So for example, we know that in 1 minute, there are 60 seconds. So this right here is an equivalence statement. And to write these as conversion factors, which are ratios, there's two different ways we can do it. We can say 1 minute per 60 seconds, or we can say 60 seconds per 1 minute. So both of these are the conversion factors. Now, which conversion factor you're going to use depends on which unit you're starting with versus which unit you're going to. So a little kind of math tip and reminder that will help with doing these is, let's say we're starting with 5 minutes, and I want to know how many seconds that is equal to. So because these are units that you're familiar with, this is something you might be able to do in your head, and that's fine. But I want to show you this dimensional analysis process using conversion factors with something familiar so that you see how it works and then can use it for unit conversions that maybe aren't quite as simple. So you're always going to start with what you know, which is in this case is the 5 minutes. Now I'm either going to use the 1 minute per 60 second conversion or the 60 seconds per minute conversion. So what you want to remember is anytime you have a unit on top and you want to cancel it out, that unit then is going to be on the bottom of your conversion factor. So when units are identical, they cancel. So let's say in this particular conversion factor, unit 1 is equal to unit A. So I'm converting unit 1 into unit A. So by putting my conversion factor with unit 1 on the bottom, it cancels with my original unit 1 on the top and puts my new unit A on the top. So let's see that with kind of units we know. So minutes currently is on top. So to get rid of those minutes, which I no longer want, I'm going to put minutes on the bottom of my conversion. That's where I'm starting. And then where I'm going will go on the top of the conversion. Now I'm going to look and see and recognize that this is the conversion factor that I'm using. So that means the 60 seconds on top, 1 minute on bottom. So minutes on top cancels with minutes on bottom. Now when you do this math, any numbers that are on top, you multiply. And then you're going to divide by any numbers on the bottom, which in this case is just a 1. So 5 times 60 is 300. So there's 300 seconds in those original 5 minutes. Okay, we'll do plenty more of these. I just kind of want to give you that preview. So here are some of the common equivalencies and conversion factors that we might use throughout this course. There are plenty of others out there. This is just a brief table that shows you some of the relationships between the metric system and the English system that we're used to. So the left-hand column are the equivalencies or equalities, as this slide is calling them, where you're saying one thing equals another. So 1 inch equals 2.54 centimeters, or 1 meter equals 39.4 inches. That's the equivalencies. Then you have your two options for conversion factors, where you have either inches on top, centimeters on the bottom, or centimeters on top and inches on the bottom. And again, which one you're going to use is going to depend on what unit you're starting with versus what unit you are converting to. Let's look at an example. So this is telling me that I'm converting 4 inches into centimeters, and the math's already been done. It's telling me that there are 10.2 centimeters. But I want to know what conversion factor was used to get that 4 into 10.2. So again, you're going to start with what you know, which is the 4 inches. Then in the conversion factor, if inches are on the top, it has to go on the bottom so that they cancel. if I'm relating inches to centimeters, the centimeters will then go on top. Now, if you look back on the previous slide, you'll see that we have 2.54 centimeters is equal to 1 inch. So the 2.54 goes with the centimeters and the 1 goes with the inch. So you're going to do 4 times 2.54 divided by 1, which is not necessary, and that does give you the 10.2 centimeters. So again, use your units to tell you if you're going to be multiplying or dividing using the conversion factors. So what I've been kind of showing you here is this process called dimensional analysis. So this is going to kind of put it into words for you. So when you're converting a unit from one system to another, or even if you're converting within the same English or metric system, it's the same process. You want to identify what you know or what you're given, so both the number and the units, and then the units that you're trying to convert into or what you're trying to determine. So you're going to multiply the given quantity by one or more conversion factors. Sometimes you do need more than one. And you're going to do this so that your original units, which you no longer want, will be canceled. And the only thing left are the units that you are trying to convert into. And by doing that, units on top cancel with units on the bottom. And then you'll actually do the math where you're multiplying across the top and dividing the numbers across the bottom. So let's try this example. It says we have a golfer putted a golf ball 6.8 feet across a green, and we want to know how many inches this represents. So we want to identify the known, which in this case is the 6.8 feet. And then what we're trying to convert into is inches. Next, we want to try to figure out what conversions we have or know that can get us from one unit to the next. If you know a conversion that relates the unit you're starting with to the unit you're trying to go to, that's all you need. Sometimes you have to take a couple steps in between. In this case, it is what I would call common knowledge that there is 12 inches in 1 foot. So there's your equivalency. So my two conversion factor options are 12 inches per 1 foot or 1 foot per 12 inches. So I'm going to start with my known, which is the 6.8 feet. Then my conversion factor, feet are on top to start. So that means feet have to go on bottom of the conversion so that they cancel, which means inches, where I'm going, is on top. So I see then that this is the conversion factor I want to use, which puts the 12 on top and the 1 on bottom. So if we do the 6.8 times 12, we come up with 18.8 inches. We do need to keep significant figures in mind. I have 2 sig figs in the 6.8 feet. This 12 and 1, these are exact numbers. There's exactly 12 inches in 1 foot, so they are not considered with determining sig figs. So we are stuck with the 2 sig figs from the 6.8 feet. Currently my answer has 3, so we will round this. The 8.8 is going away, which rounds this up to 19 inches. Here's another example. We're going to convert, or we have an iron sample that has a mass of 4.5 pounds. I want to know what this mass is in grams. So we're starting with the 4.50 pounds, and we're trying to decide how many grams that is. In this case, I'm giving a couple of equivalencies that we could possibly use. So we're starting in pounds. These equivalency, I have pounds here. That can take me to kilograms. Then the second equivalency, I have kilograms. That can take me to grams, which is where I'm trying to go. So just make sure you have that path with any conversion factors or equivalencies that you know, and you can get from one unit to the next. So we're going to start with the 4.50 pounds are the known. Then in the first conversion, I know the pounds have to go on the bottom so that they cancel. If I look at my options, this first equivalency is where I have pounds. So that's going to convert me to kilograms on top. So the 1 kilogram is 2.2046 pounds. Now I'm in kilograms, which isn't where I want to be. I want to be in grams. So the next conversion, the kilograms need to be on bottom, so that disappears, and put grams on top, which is where I want to end up. So if I look at this equivalency, it's 1 kilogram is 1,000 grams. So my pounds cancel, kilograms cancel, I'm left with grams, which is what I'm trying to calculate. So here the math would be the 4.50 times 1 times 1,000 divided by 2.2046. And there's a 1 here, there's a 1 here. You don't have to divide by 1. We also don't need to multiply by 1 here. So 4.5 times 1,000, 4,500, divided by 2.2046. Plug that into your calculator and you will get, oops, I plug it into my calculator. There we go. We get 2041.18661. So that's the unrounded answer. Let's go back and think about sig figs. So our original known number had 3 sig figs. All of these conversion factors are going to be exact numbers unless you have something that looks like this where there's a bunch of kind of random, it feels like random decimal places. But usually these conversion factors that we give will have more sig figs than what your original number does, but something to keep in mind. So the 1 kilogram is exact, this 1 kilogram is exact, this 1,000 is exact, this 2.2046 is not exact, but that's 5 sig figs compared to the 3 of our original number. So our final answer is going to have 3 sig figs. So this 1 is the first digit that goes, so 2040 grams would be the answer rounded to the right number of sig figs. Now these problems take practice. You'll have lots of practice in your homework, so the more you do, the easier they will get.